I made changes. It almost made me late. And yet, here we are, roughly on time, 24 hours late. Other than that, hey, welcome to ADRAMADA. Another Dave Rush Ask Me Anything Digital Alchemy. And I am the aforementioned Dave Rush. It's been such a week. Sorry, I'm reeling from it. I'm so glad to be here. This is wow. I wonder if you heard that. It was a very large sneeze that came from another part of my house. Anyway, we get together normally every Thursday, and what is going on here? My whole world is blowing up around me. We get together normally every Thursday at 7 p.m. Central Time and talk tech news, talk whatever's interesting that comes rolling by. We heard it, okay. They heard that, dear. That's it. I'm going to be on a laughing jag for the rest of the evening. Today is not Thursday because last night at Showtime I was in Beaumont, Texas. 4 days. There's 5 days a week. The first 4 days of the 5 days, I was in 5 different cities doing my side thing. So it's just been busy, busy, busy. On days that I teach classes, I have to teach up until the last second, and then I got to be ready to head out the door for, in most instances, to get where I'm going. I've been in Houston and Waco and the Woodlands and Nacogdoches and Beaumont this week. Next week, I'm up in North Dallas on Wednesday, back to Beaumont on Thursday. I'm back to Beaumont next Thursday, which means there will be no show next Thursday. We will do part 4 of Subnetting next Friday. And the following week, we've got Maxine Hayes coming on to talk to us about Plan 9 and where it does or doesn't fit in the educational world. That's her area of expertise right now. She's such an expert in so many different arenas, but she had written an article on Plan 9, and I didn't know much about, I still don't know much about Plan 9. She does, and I did a little research and said, oh, we've got to get this nice lady to come talk to us. She's been happy to agree to that. Anyway, show is devoted to collecting and disseminating information on technology and its uses, and in particular we're interested in how the advancement of tech impacts our daily lives. Now I'm getting a little really kind of niche specific in this last couple of episodes. I'm doing it for a few reasons. We're talking about subnetting, which is not a broad technology that everybody needs to get into, but I'm doing it because I've taught it before many, many times, but never in a way that it left a permanent record anywhere. And many people have asked me, because I teach so many other things, why don't you do a subnet masking? And I thought, well, or subnetting. You know what? I've been promising myself to do that, and I thought this was kind of a good place to start. And if it all comes out very well, I'll download these episodes, edit out this junk, and get right into the project, and then edit those all together as a series, or a series of 4 and something like that. Or I'll use that as kind of a trial balloon. I'll review them and do fresh set on them. But it's gone pretty well so far. I'm happy with it, and I think I'm going to be happy, and you're going to be happy with where it goes tonight. So after tonight, after tomorrow night, we move back into broader-based technologies. I'm doing this in part because there should be a record of it, which I would probably call Me Too. Thousands of people have done tutorials on subnetting. But in all of the ones that I've ever watched, nobody does it the way I do it. I've gotten an interest into it, and we're going to get into that tonight. So, hey, eep, op, or ah. Oh, I didn't do all this stuff in advance because I was rushing. Ready, but rushing. So, putting up on the chat feed as we sprechen various platforms that I'm on and ways to contact me. It's 2 for 3. There's some email addresses and our Discord server. Man, if you are not on our Discord server, and relatively speaking, we got a lot of new members to our Discord server this week. It was very surprising. I asked 1 or 2 what triggered this, because I see them join mine and I see them join another one that I'm a member of, and I don't advertise my existence over there. They don't advertise their existence on mine. So I'm wondering how and why people are finding the both of us together. And I got an answer from one person, but it doesn't seem like it should fit the mold. I was just looking around for Discord servers, and I found yours, and I found that one. Okay, well, it's not surprising that they would be uh, advertised or noted in some of the same places. We have some co-history, but anyways, we got a fair amount of new users, which doesn't mean a lot of new users. 4 or 5 for us in a week is a huge number. We're just a tiny, friendly little server with channels for all kinds of tech. So if you're not a member of our server, come on over, join us. The link is in the chat feed, and you are ready to go. So last week we did part 2 of 4 on subnetting. Part 1 was how to convert back and forth between binary and decimal. It's a critical skill if you are in the networking arena. Second week, last week, we did what's called classful IP or network addressing. And that says this is how networking and addressing was invented in the earliest days of IP version 4, IPv4. And there are rules about how to use them, and they're very easy to understand rules. They don't require any planning, they don't require any thought, but you get what you pay for. They were new, and they were designed for an environment that doesn't come close to the universe that we are in today as far as IP and networking. But they're still absolutely foundational to help us move on to today's episode, part 3, which is going to be actual hands-on subnetting. We're going to get through a fair amount of it. We may run out of time. That's okay, because I've planned to extend this into next week. And we are sliding past that. So I want to dive straight into news. I want to get through material quickly today. First of all, let's see who's hanging and who's not. Not many people here yet. That's a Friday night, and I don't blame anybody for not being here live. But we get plenty of viewers coming on after and watching the archive. So if you're not watching this on the or if you're watching this on the archive, we did this on Friday night, and we encourage you. Check out, keep an eye on the banner page and see what day we're going to be on this week and what time. And it's a lot of fun when you guys are here and live because we can interact. Really appreciate that stuff. All right, so let's do news. Oh, that's weird. Yeah. Hang on, look at the slides. Oh, no, Nelly. I'm going to slides for today's news. All right. And I know why. I was distracted. I could have had them. I've only got 4 news stories this week, and the slides aren't particularly informative. They're just entertainment when we do these things. But I kept the news short again because I got a lot of content on the project today. And because, as I mentioned the other week, it kind of dawned on me that people watch these into archives years into the future. I have old stuff that's been up for 3 or 4 or 5 years now. And anything that I would have put in the news on those early shows would be 5 years old now. And you're just going to skip right over that. So I'll try to keep news short, and I'll try to keep it future-proof, or maybe archival, so that when you are watching this in the future, you'd say, "Oh, that's when Dave talked about it." So, last couple of weeks, we have made mention of this asteroid that's in solar orbit, and it got spotted not too awfully long ago. It was actually spotted a very long time ago, but only recently did somebody look at some of the old photos and compare and say, "Hey, look, there's an object in an odd place." And here's in a really odd place. It's not moving with the rest of the universe. It's an asteroid. And I think it's called FY24 or something like that. And they looked at these first couple of slides and said, okay, we're going to make a rough guesstimate of how close it's going to come to Earth. And the numbers were kind of scary. There was a 2.3% chance, which is huge. Okay, that's really big chances. And then they upped them to 2.8 or something. And eventually, late last week, early this week, it was up to a 3.1% chance. Now, that's about a 38 in 1. If you play the lottery, you believe that you have a chance of winning in an odds that's 300 million to 1. So if you take that seriously and you look at something that's got a 38 to 1 chance, that's what? A million? 10 million times more likely than winning the lottery? So, anyways, earlier this week, NASA's been making the best observations that they can of this thing for the last couple of weeks. And this week, they changed it down to about a 1.4% chance. Okay, so still a chance is going to hit us. Cosmologists expect that number to drop as more observations are made. Here's the problem, they say. This asteroid is presently on an outbound trajectory. So they're waiting for it to orbit and make a turn and start coming back in. And then they say they can get more accurate measurements and come up with a more likelihood. So, all right, they're saying the numbers will probably drop when that happens. Maybe, maybe not. I'm looking at that. I'm kind of the cynical type. I'm wondering if this new news is just part of an elaborate scheme to calm the masses. For all I know, the odds are 1 in 2. No, don't worry about it. But fortunately, there are amateur astrologists, astronomists, whatever, stargazers, who will also make their own determination. It's a free and open source community when it comes to that. I tend to trust those a lot more than anybody from the government, even with people who are supposed to have such lofty goals as NASA. Slide 2. I thought this was an interesting, no slide. I thought this was an interesting little news tidbit. The weight loss drugs, which are not weight loss drugs. Those are a side effect that people are using them as if it were a primary effect, and they're using them in what they call off-label ways that weren't approved by the FDA. But if it's an approved drug, a doc can prescribe it for any purpose that he believes it to be useful. So Ozempic and Wegovy and whatever that other one is, they all have 1 or 2 different hormones in them. They started developing these things in the late 80s, early 90s, when some researcher said, I'm looking for a hormone that does blah, blah, blah. And it's all about diabetes treatment. That's the nature of these original things. So he starts researching for things that already exist that way that he can either use or try to duplicate. And what they found is Gila monster poison. So they're not milking Gila monsters, which would really be cool, but they have synthetically created at least one of the major elements of Gila monster poison, and it got approved. With all the news that you hear about it in the last year, 18 months, you would think that this is the latest wonder drug. No, the approval for diabetes and the discovery that it had weight loss side effects to it started around 2005. And I got a little bit interested in this because one of the events that I did this week was heavily attached to these drugs. So I thought it was interesting. I think it's been around for a long time. It's been around for 20 years. After 20 years, I think patents start expiring. So that'll be interesting to see where that goes too. But Gila Monster and Ozempic, integrally linked. News yesterday. DeepSeek. You know how much I hate talking about AI. If you don't, I hate talking about AI. I just don't like the hype. I don't like the misleading name. It's not intelligence. All right, I'm going to go off on my rant. I'm not doing that. Anyways, DeepSeek comes out a couple of weeks ago. Bigger, better, stronger, faster, cheaper, blah, blah, blah. And your data is safe. Well, that was always suspect from the very beginning. Korea? South Korea? Uh, Vietnam? One of those two governments did a massive test on security and data integrity and discovered very easily that personal data, when people are doing prompts and they're providing information about themselves to help the prompts, are going effectively straight to Chinese government. So whatever country that was, they immediately froze use of it on anywhere in their country. The civilians aren't supposed to use it. The governments and militaries absolutely forbidden. So I'm curious to watch that, where that will go on a worldwide basis. We had the TikTok thing here, and it's kind of sort of back up now. I don't know where they're going to go with that, but if a nation can ban use of an application, I've wondered about that ruling because I can't understand where it gets that authority. I've certainly never seen anything come out of the Supreme Court that allows that, and this never went to court, at least that high in the court. So I'm really curious about that. But I think this is going to be an interesting one to watch. It was too new. It's too good to be true. It's very good in the confines of what AI is supposed to be and do. And blah blah blah. Okay, so it's got major data. There we go. And then the last of my news items this week, one piece of computer news. Usually when you read the computer news, it's this version of such and such is out, and that version is out, and these are the new benefits of this. And I'm starting to shy away from those because, again, in that eye of future perspective, in just a year, that'll be such old news. Oh, we've been doing that and way, 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 way more for a year. So this is a product called DistroBox. It's not a particularly new product, but it is new. And what DistroBox allows you to do is, in some kind of container, like a Docker container or a Podman container, you put a Linux distro of your choice. It's tightly integrated to your hosting Linux distro. It shares with your personal home directory in there, and external storage and USB devices, and the graphical environments, X11 and Wayland. So what it means is you can have, without running virtual machines, a bunch of different distros running in your Linux system. Anytime you're running stuff like this, it needs memory, and it helps to have a powerful CPU. But I just read about it today, and you can bet your bottom dollar that over the next 7 days or so, it'll be installed on one of my development distros on here. I want to see that thing. It looks really interesting. Benefits, making test environments, making changes without affecting your primary distro. That's what test environments are, right? Good for testing programs in a test environment. Try out the latest Linux distro features before they arrive. I like that. I love that a lot. You can try new desktop environments before they officially arrive. That's cool, running a desktop environment in a container that's basically kind of like a VM, except it's not a VM. All right, so that's all of the news that's fit to print. Sliding down my notes. That's what we want to do next. Buzz, buzz. Tomorrow morning, 9 a.m., I'm going to be at our mutual friend's house again. I was there twice last week, and going again tomorrow. I'm not stunningly clear on what we're doing. So I'll let you know after it happens. I got broad strokes, but they're up to interpretation as far as that goes. So that's going to be it. All right. Let's see who's chatting about what. It's all television. It's all probably me and you. Actually, we got 5 people here. Joey's here. All right. So AI is our friend. Yes, I, for one, welcome our new AI overlords. If I only knew the evil you've been up to, I don't want to know. You know, if you're finding positive uses for it, more power to you. I got my own bent on it, but I'm not always right. I'm always right. It's just not everybody recognizes. Joey Quetzal, hola mi amigo. Good to see you, my friend. I know you don't speak Spanish. I'm in Texas, all right? I throw some Spanglish in every now and again. Yeah, ready for show. Cool. Same old timers, yep. Jason's here, who experienced yet more snow in the Carolinas, and good story today about Butterbean. That was cool. Will Shaw's here. Where did I miss that? Oh, there he is. Will, my friend, you're back from the Pacific. I totally can't wait to hear about that. Catch us on Discord, sometime in your travels. You know me, I'm always on if I'm not sleeping. I go to sleep at midnight and get up at 6 and 5, depending on my needs. Please don't forget the video. I apparently have already forgotten it. Oh, like the video. Yeah. Thank you. I liked it. As soon as I set it up, I thought, I want to beat Tolowit for a change. Okay, you can sit there and be quiet. Quiet, but here. Very good. All right, well, let us dive into it. What I've got today is I didn't get quite as far as I wanted to last week when we were talking about classful addressing. Just a couple of slides, 2 informational slides that are speedy, and then I've got 3 practice things. And they're here because you're going to forget a lot of what we did last week, so this is kind of a helpful reminder. And by the way, if you want these slides so you can watch them at your own pace at home, I will put them up on the Discord server as downloadable. So you can have them all and experiment with them. All right, let's go find Uncle. Oh, I don't want to do that. This. Try again. This. There we go. Click U, transition. Section 8. Oh. Okay. Now. So what I wanted to do is this is a summary slide of classful addressing. And this is a reminder of something we learned last week that says you can determine if a network is a Class A network or a Class B network or a Class C network simply by looking at the value of the first octet. So if the number in the first octet falls between 1 and 126, it's a Class A network. And we're talking about classful rules still, so simple enough. And let's stay on that line. The default subnet mask for a Class A network is 255.0.0.0. And we shortcut that by saying if we wrote that in binary, there would be 8 ones and 24 zeros. We count the ones from the left. It's always from the left. And we'd say, okay, that's a WAC 8 subnet mask. So 255.000 and WAC 8 mean exactly the same thing. There are exactly 128 Class A networks, and each of them has 24 zeros to make host addresses. 2 to the 24th minus 2 is almost 17 million host addresses for each Class A network. We talked about why that's a bad thing. In short, because some company calls up and says, I need 100,000 addresses. And they said, we can't give it to you. There's not enough addresses in a Class B. There's not enough addresses in a Class C. And we don't carve them up here at the, who are at the elders of the internet office. So here, you can have a Class A. Cool. I just got 16 million addresses out of the 100,000 that I need. And then they sit on the rest of them. Actually, we sell them now, but all right. We look at the value of the first octet, and we discover that it falls between 128 and 191, inclusive. That makes it a Class B network. Class B network default subnet mask is 255.255.00, which makes it a WAC 16. There are 16,000 or so Class B networks, and each of them has 16 bits left over, the other 2 octets in the IP address, to make host addresses. So there's 65,000 or so host addresses for each of these 16,000 Class B networks. If you called up the elders of the internet back in the day and said, I need 1,000 IP addresses, they said, can't help you because Class Cs are too small. I'd have to give you 4 Class Cs, and I can't do that. So I'll have to give you a Class B. Here you go, Class B. You just got a block of 65,000 addresses, but I only need 1,000. Well, hang on to those 64,000. They might come in use later. And then finally, if the value of the first octet falls between 192 and 223, you've got yourself a Class C network. Class C network subnet mask 222.55.0. That means the first 3 octets are the network address, and you have 1 octet left over for host addresses. That's 8 bits. 2 to the 8th is 256. You got to take 2 away from that, 254. But there you go. So that was just kind of a summary. We covered all that last week. I just wanted to review it. And this is something we didn't cover last week. These are called special IP addresses. They're not part of subnetting, but they're such a natural component of the flow of this discussion, and it only takes one quick slide. I thought I would do a little speed review on this. Special addresses are special in part because they can't cross routers. They can't go onto the internet or over the internet. Some of them can't even leave your computer. Some of them can leave your computer but have to stay on the local area network. So, for instance, anything starts with 127. Hey, wait a minute. Let's go back for a second. Class A networks fall between 1 and 126 in the first octet. Class B starts at 128. They've got a missing one in here. 127 is not in this list. That's because it was made special, and it's now called the loopback address. That's when your computer talks to its IP software. If you send a message to 127.anything.0.0.1 is the common one, you're talking to your own software inside your computer just to test and see if it works. Nothing leaves your computer. I was looking at a utility today. I was working with it, and it had a loopback in it, and it was 127.004. That's so unusual. But again, you can do anything from 127.255.255.254 down to 127.0.0.1, and that all is the same thing. It's all the loopback address. 169.254.anything. That's called an APIPA address. That's what happens to your computer when your computer calls out to a DHCP server and says, I need you to assign me an IP address. And the DHCP server doesn't answer. He's offline. He's unreachable. So your computer, your Mac machine, your Linux machine, your Windows machine, it'll try again and again and again for a minute or so. Varies by operating system. And when it finally says, oh man, I got to give up, I am not getting any response here, then it will self-assign an APIPA address, automatic private IP address. And you can always recognize an IP address, an APIPA, because it always starts with these first 2 octets, 169.254. They're not routable. They exist so that I can do some basic communication on the network with other stations that have APIPA addresses, and so that if I look at this computer's IP address, and I see that it's got 169.254, that tells me this machine wasn't able to reach the DHCP server. And so now I've got some thoughts on how to go troubleshoot. I can look at physical connections, are switches turned on, or things plugged into this computer, is the DHCP server up and running, whatever. And then finally, we've got some blocks of addresses. I didn't do them all, but I did the block of Class C private addresses because so many of us use those 192.168.0.anything through 192.168.255. That's a block of private IP Class C addresses that most small office and home offices operate. There's also a block of Class Bs, 172.16 through 172.31, and there is a block of Class A's, 10 dot. And that's that. Okay, so we did classful addressing last week, and given the review that we just did, I want to look at this and I want to ask you a question. You're looking at an IP address here, 217.6.44.185. Based on what we know, we should be able to fill in the 3 boxes down below here. So the first thing we want to know is, what class is it? And we just said, in order to determine a class, all you have to do is look at the value of the first octet, and you have to have memorized this stuff. Is it between 1 and 126? Then it's a class A. Is it between 128 and 191? It's a class B. Between 192 and 223, it's a class C. So let's go back and look at that again. It's 217. That sounds like it falls between 191 and 223. So this is a class C network address. Now we know that class C networks or network addresses have a default subnet mask. And in classful addressing, there's only 3 default subnet masks. There's WAC 8, there's WAC 16, and there's WAC 24. And they're really easy to remember in order because A is the WAC 8, B is the 16, C is the 24. This is a class C, so the default subnet mask on this should be WAC 24, 255.255.255.0. And once we know the subnet mask, we can determine the network address portion of this IP address. Wherever the 255s are over, those make up the network address. So there's 3 255s in here, 1 over the first octet, 1 over the second octet, 1 over the third octet. And any leftover octets when we're writing down a network address are zeros. So the network address on this guy is the first 3 octets and 0. 217.6.44.0. See if I got that right. It's a class C. Default mask is 22255 or WAC 24. And there we go, 217.640.0. Let's try it again. Here's a new IP address. 99.138.252.12. To determine its class, we look at the value of the first octet. Class A's fall between 1 and 126. Well, I'm done. I know now that this is a class A network because the first octet is 99. Next, the default subnet mask. Well, since it's a class A, we mask off the first octet. That's how we figure out the network address. So it's 255.0.0.0 or WAC 8. And the network address then? Whatever octets are underneath the 255s followed by all 0 octets. So this network address is 99.0.0.0. All right, it's a class A network because the first octet's between 1 and 126. The default subnet mask of a class A network is 255.000, and therefore its network address is 99.000. One more. Last one. Got an IP address, 160.170.219.11. What's its network class? We look at the value of the first octet and find out, does it come into the class A range, the B range, or the C range? Network professionals, these need to be committed to memory. You live and die on them every day. So 1 to 126 was class A. That's not there. 128, because we skipped 127, through 191 is class B. Hey! 160 falls between 128 and 191. This is a class B network address. That takes care of the first part. The default subnet mask, it's a class B, so the mask has a pair of 255s in it, 255.255.0.0 or WAC 16. And its network address is anything that's under the 255s followed by zeros. 160.170.0.0. You think I'm looking at an answer sheet up here in front of me, don't you? Nope. You can do this. This doesn't take long to get it to memory. So, all right, that is the review and everything from last week. And so now we start into subnetting, which is a nickname. Subnetting means taking networks and breaking them up into chunks of that network, chunkifying them, segmenting them, subnetting them. The official name for subnetting is Classless Inter-Domain Routing, or CIDR. We came from a classful background last week and the review just a moment ago. Now we move into classless. It seems like a bad thing to go from having class to having no class, right? But no, that's only a human failing if we did it that way. In this case, we get a lot of benefits by violating the classful rules and becoming classless. So here we go. Why are you there? I had a duplicate slide. That should screw things up really badly. Because I have my slides numbered and associated with my notes. Oh, I'm nervous. All right, what do you do? Okay, I can do that. So, here we go. To understand classless networking, we have to have a foundational understanding of classful. That's why we did what we did. Working with the original 4B, I'm going to type one here. All right, so way back when, working with the original available addresses, the elders of the internet realized that they needed an organized way of passing out blocks of IP addresses to internet users and service providers, and so they made these 3 block sizes. That's why that slide was there. It was actually legitimate. So it was a review slide, and there's our 3 block sizes. It's exactly the same slide we saw a couple of minutes ago in the review. And as I covered that, I covered the problem with it. They only handed out complete blocks. This company needs at least this many. That's an A block. This company needs just this handful. We'll give them a C block, this organization. But when you look at that, there's not that many total blocks to give out. 2,016,200 or so. So as soon as 2 million organizations reached out and said, oh, elders of the internet, I need a block. And they gave them one that would best suit, or, sorry, I don't have any left over that'll suit you. But, you can have one of these. It's not suited for you. It's too small or it's too big. But if you want it, here it is. We'll register it to you. And sure enough, that's what happened. So it didn't take awful long, less than 20 years, to run out of these addresses. And so they fixed that with NAT, and they later fixed it with IPv6. But not where we're going down this road. So they call these blocks classes, and the mask became a critical function, the subnet mask, in defining network addresses within a class. That's what we came up with. Our class A is not only our class A because of that first octet value, but because the first octet is defined as the network address. And how do we define that? Because we give it a subnet mask, or we give my computer a subnet mask of 255.000. Same for the B's, different block range, different subnet mask, a pair of 255s. And same for the C's. Different first octet range. We use the first 3 octets as network addresses. That was a whole bunch of things here. Did that. Heck, I'm all over that. Oh, I see what's going on. Dang. Okay. All right. That is slide 22. Slide 23. The classful review did that. Network addresses and broadcast. Okay. All right. This matches my notes. I am where I should be. Sorry about that. For every network address all of the octets that follow the address octets are used for host addresses. So for instance, we have this network address on the first row that's address 96. This actual network address is 96.0.0.0. And that means, in theory, I can have host addresses that start at 0.0.0 and then the increment 001, 002, 003, 00255, 01.0.2.0. And I keep doing all that until I get about 16 million addresses. But it turns out that for any given network address, there are two addresses that you cannot assign to hosts. And one of them is all zeros. So if all of the octets that follow a network address are set to 0, that's not a legal host address. So if you're using a Class A network, you can't have 3 zeros following the network address in a host as its IP address. In Class B, there's 2 octets available for host addresses. So my second column, I got a network 131.77. We write down his network address as 131.77.0.0. That's the nomenclature for writing down a network address, and that's why we can't use all zeros in the host positions as an IP address. And then down on the bottom of the row, we've got a Class C network, 222.7.40. His network address is 227.7.40.0. No host can have that .0 address. And then the other address that you can't have for all of the host octets is all 255s. This first example, if we were to ping 96.255.255.255, that's the network broadcast address. That would send a ping to every computer on my network 96. So we can't assign that as an individual host address. In the Class B, I can't put a pair of 255s as an individual host address. In a Class C, I can't have a 255. This is going to matter here in short order. So what I've got here is we're going to start out by looking at a subnetted network. I got a router here. It's got 6 ports in it. One of the ports up on top has an IP address that came from on high and allows us to connect to an internet service provider on the internet. That's at 121.4.207.11. He doesn't enter into this conversation. He was just there to make it look official. We're going to work with a typical in-house SOHO network, a Class C private network 192.168.1.0. The problem is I have to put everybody on the same switch system, 254 possible stations on the same switch, or switch system, series of connected switches, and everybody can talk to everybody. And while that's not going to cause collisions because those don't exist anymore, it's a management problem. I don't know who's on which switch in any organizational fashion. I don't know which department is using which switch. I don't know which floor is using which switch, which building in the campus. I've used all those examples before. So what I've decided to do is to break this block of 254 addresses into 5 chunks. And each of those chunks, I am temporarily, for the sake of our discussion, calling them networks by letters. So this leftmost one is a subnet. This is a chunk of a network, so it's a subnetwork, and we're calling it subnet A. Next one, subnet B, subnet C, D, and E, moving over. So I got this interface here, this leftmost interface in my router, and it's going to a switch, and everybody attached to that switch has to have an IP address of 192.168.1, subnetwork A, and then some host addresses. Same thing on the next switch over, except for subnet B, and the next switch for subnet C and D and E as we go along. When anybody on switch D sends out a message, it's going in one of 2 places. It's either going to the default gateway this router out to the internet, or it's going to somebody on its local area network. The E people don't get to talk to the D people, don't get to talk to the C. Yeah, we can and they will have to, but for now, this is the point of subnetting. It allows me to put people on what looks like different networks or different network addresses, and so we can keep sections of traffic isolated. I'm doing hand gestures on here and you can't see my face, sorry about that. But they're on these, not isolated, but organized sub-chunks of the network. Now, procedurally, this is actually very easy to do, but we've got to get over a little bit of a hump here. So I've taken a Class C network. Just a straight up example, just a pick one at random, 214.80.70.0. And we start in our magical world with classful addressing. So it has a default subnet mask of 255.255.255.0. First row under the title there. That's a WAC 64. I'm sorry, WAC 24. And so what I've done is I've written down the IP address in a combination form, decimal and binary. So in decimal, the first three octets, 214.80.70, those all fall under the 255s, so those are the network addresses. And then I've written this last octet down in binary. It's not masked, the mask is a 0, so I've got all the possible values for host in here between 000000001, that's a total of 8 characters, can't have all zeros, right? And 1111110, which is 254, can't have all ones because that would be a broadcast. And so that's what we're saying in the next two rows, 214.80.70.0000000 through .111111111. That would be a .0 address or a .255 address, and that's not legal. At least those two. Everything in between is legal. So the reality, the next to the bottom row here, 214.80.70. All zeros and a 1 are legal host addresses through 214.80.70, all 1s and a 0. So there's 254 of those addresses. There's a formula I'm going to give you that's really easy to remember and use that'll help you calculate that later. All right, so rewriting this again, this is just another different way to rewrite what I did up on the first line. On the bottom, we've got decimal 214.80.70. Binary zeros, and up on top, I wrote the subnet mask, except I wrote it in binary, because that's what we're going to do when we're doing real subnetting. We think and work in binary much more easily than in decimal. So I got 8 ones over the first octet, 8 ones over the second octet, 8 ones over the third octet, no ones over the fourth octet. So that's a 255, 255, 255, 0, or WAC 24. Sweet. Now what we're going to do is subnet. That's it. We're ready to start subnetting. And subnetting in Dave's speak, in Dave process, is a 4-step process. The first step is to ask and answer the following question. How many chunks do I want to break my network up into? If I got a Class C network address, there's not many chunks that I could break that up into. I've only got 254 possible nodes. You know, I could break it up into 2 chunks or 4 chunks or 6 chunks. That would be plenty. If I had a Class B, that's got 65,000 possible host addresses. I need a lot more chunks in a Class B network than I would in a C. And a Class A, with its 16 million, I need 10,000 chunks more, depending on my network. And that's why for today's session, we're going to do all of our examples with a Class C network because it's simple to lay down. So, first step in subnetting, how many chunks do I need? And for my first example, my answer is going to be 2. The second part is, having answered the question, how many bits do I need to come up with the answer to my question. How many bits does it take to identify the number 2? And fortunately, the answer is really easy on that one. It's 1 bit. 1 bit can have 2 values, either 0 or 1. That's 2. So what I'm learning here from this, I know this doesn't make sense to you yet, don't panic. I can use 1 bit to create 2 subnetworks, and I will. And the point of subnetting, now we're ready to slide, advance, is to borrow bits that are normally used for host addresses and to treat them as if they were network addresses. So I just said I need 1 bit to make 2 networks, to make 2 chunks out of this 1 network. So I'm going to borrow 1 bit from the 4th octet, the host octet. And it's always going to be the leftmost bits that I steal or borrow, depending on how you look at it. Now, if we look at this graphic here, I have 3 sets of 1s for a subnet mask. And the way I'm going to borrow 1 bit from the left-hand side of the host octet is I'm going to extend my subnet mask from being a WAC24 to being a WAC25. Notice up on top, I now have 8.1s.8.1s.8.1s.1 and 7 zeros. 0, 0, 0, 0, 0, 0, 0. That means I'm borrowing the first bit of that octet. Now I've rewritten that down lower with a little vertical line there. That bit is in the 128ths column of the octet. Remember, we've got 8 columns in the octets, and if we look at them right to left, it's 1, 2, 4, 8, 16, 32, 64, 128. So I'm going to borrow the 128ths column, and I'm going to treat it as if it were a network address. So I'm going to forget for the moment that I have an actual network address, 214.80.70. I always will. That's cool. But now I'm going to say on network 214.80.70, I have 2 possible subnetworks. And they are determined by the value of the bit in the 128ths column of the last octet. We're going to enumerate these subnet addresses in a moment. In fact, I've already got it on this slide, so let's stick with it from there for the moment. If we put a 0 on somebody's IP address in the 128ths column, look over at the label on the right side here. They are on network 0. Because of binary decimal conversion 2 weeks ago, we said if there's a 0 in a column, you multiply the 0 by the value of the column, and you're going to come up with 0. So this is subnetwork 0. I wrote down network 0 because we're pretending this is a network. Reality is it's a subnetwork 0. If I give somebody an IP address in their 4th octet that starts with a binary 1 in the leftmost column, then they're on subnet 128. There's a 1 in the 128th column. That puts them on network 128. That is step 3. Collectively, it's borrow the needed bits from the left side of the leftmost host octet. We're going to do an example where we need more than 1 bit, but for now we'll just borrow the 1 bit. And then we enumerate the subnetwork addresses that come from the borrowed bits by sticking 1s and 0s in them. So there's only 2 subnetworks to enumerate here. Networks subnet 0 and subnet 128. Now we get the fun part. Step 4, the final step. And I think this is as far as I'm going to get to tonight. Maybe a little bit more. I got 6-7 minutes now. And that should be cool. Step 4, determine the number of hosts and assign the host address ranges. All right, each of these 2 subnets, subnetwork 0 and subnetwork 28, has 7 zeros, 7 positions left over to make host addresses. In theory, I could have 7 zeros and every combination starting from there to 7 ones. Oh, but the classful rule applies. You can't have all zeros to the right of the network address or to the right of a subnet address. And you can't have all ones to the right of a network address or of a subnet addresses. So to figure out how many hosts I can put on subnet 0, I count the leftover bits that I have to assign to host addresses. There's 7 of them. I used the 8th one to be a subnet address. So I can't have 7 zeros and I can't have 7 ones, but I can have everything in between. So here's how you figure it out. You say 2 to the 7th minus 2. And that's going to tell you how many hosts you can have on subnet 0. Looking down here at the bottom of this graphic, I've taken the top right-hand side of the graphic and I've expanded it, blown it up to be the whole bottom here. So let's work on the bottom of it now. 4th octet, the leftmost bit is subnetted. The top row is on subnet 0. There's 7 zeros following that for host addresses. I could start with 0, 0, 0, 0, blah, 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 1 through 1, blah, 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 0. And if I apply my formula to that, 2 to the 7th minus 2, I'm going to discover that there are, oops, I got a typo here. I forgot to fix this one. There was it's 126 hosts. The range is 1 to 126, not 1 to 127. This second one is correct. And I went through all these slides and I found a bunch of typos and I fixed them all, but I missed this one. When I post these slides on the Discord server, that will be fixed. All right, so what that means is when I figure out what this guy's actual IP address is, I can give him an IP address in the 4th octet of 1, 2, 3, 4, 90, 100, 110, 120, 125, 126. And that would be the highest number that I could have. If I put 127 in here, that would be all, zeros. And that'd be a problem. The next set down lower, on subnet 128, not subnet 1, also 126 hosts, but the range here starts at a different value. And you just look at all the values of all the ones and the columns that they're in. 1 times 2 plus 1 times 4 plus 1 times 8 plus 1 times 16, blah, 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 blah. You get to 128, and you're going to come up with 254. That's the highest number. The lowest number, I've got a 1 in the 128s column. I have a 1 in the ones column. So that means the first host address is going to be 129. 128 and 1 is 129. All right, I got 2 minutes left. That's where we're going to leave this off right now. And that's about right. I'm going to be able to finish this and the follow-up next week. Let's go put my head up there and get ready to close things down. I'm going to make notes of that. Let's see. Fix this slide, first of all. Fix this slide. And pick up from here. Save. All right. That is the mechanics of subnet masking. There's 4 questions or 4 steps. We ask ourselves and answer. How many chunks do I need? Next, I figure out how many bits it takes to make that many chunks. So far, we've just done a network with 2 chunks, and I could do that with 1 bit. Next, we enumerate the values of the subnets that come from that. Then we figure out how many nodes we can have, hosts per network, and then step 4, we enumerate those hosts. We put the range of addresses, which has to be the first legal address, which is the last legal address. And if my class is watching this, or I've got a bunch of class members who are watching this, that's something that we didn't get into in the CompTIA material because the slides don't cover that. It is on the test, so you're going to want this. All right, let's finish up with everybody else. Let me see what everybody was talking about while I was doing that. People were making their guesses, and I didn't follow up because I didn't have this part on, so I was kind of focused on that. All right, reading messages, and then I'll close. Welcoming old timers. Hey, we got a usual count in here without some of the usual old timers. Tolwit, I had a Pupa City yesterday for clients during that network overload situation you and I chatted a little bit about. That's cool. Every time I hear whack, I think, dang, stay away from the mafia. You are hanging around Tolwit way too much. Shame on both of you. Joey, I just found out I can change my Soho router network address. Oh, yeah. The newer ones give you can pick a class C anywhere you want. Some of them will let you select from the class B private range, and some from the class A. So yeah, that's kind of cool. Troubleshooting connection to your Proxmox from your laptop. Realized Proxmox was in a separate broadcast domain as my laptop. It was in a separate broadcast domain. We have to talk about that. To be in a separate broadcast domain, it has to be on a different network. And maybe that's what you're saying here. Even though they were directly connected by the router, right, that's absolutely true. You can have stations with two different network addresses connected to a switch, and they'll never be able to talk to each other. One of them is saying, I'm calling my network Cherry Street, and the other one says, I'm calling it Main Street. And as a result, because of that disagreement, they will never talk to each other, even though you've wired them point to point, direct to direct. They have to be on compatible network addresses. That's the best. Learning as you mess with stuff. Yeah, absolutely. I did the same yesterday in my church network. That's cool. I love when it applies. Forgotten all about that stuff since Net Plus. Yeah, if you're not using this regularly, it goes away. Next week, Joey's going to be on Friday. This is not CCNA, but everything in Network Plus, 90+% of it, is on CCNA. The only difference is CCNA also has one other chunk. It's iOS, so that you know how to program Cisco equipment, their switches, their routers, and things like that. So yeah, you can pass half of CCNA with it. We recommend for people who are taking CCNA, take Network Plus, and then you're halfway done with CCNA, and you wind up with 2 certifications when you head out the door. All righty, I am going to close things down here. As soon as I learn to spell. And then we hit this button, and then we go to the close down speech. Because I don't have it memorized yet. Hey, thanks everybody. I appreciate you being here on a Friday. I know there's a million better things that you want to do on a Friday. There's a million better things I want to do on a Friday. Nevertheless, I will be back here again next Friday, finishing up subnetting. The week after that, we got Maxine Hayes. I don't know what I'm going to do the week after that. I'm not thinking that far in advance. But until then, I wish you a great rest of the week. Take care of each other. Take serious steps to stay healthy, and if at all possible, call or visit your parents. And never forget, technology is great, but the greatest resources we have are, in fact, you and I. And with that, I bid you good night. I will see you on ADRAMADA next Friday, and on the other platforms that I'm on. Until then, remember, how you do anything is how you do everything. Eat, op, or ah.